Hello friends, so today we are going to discuss this question from leetcode, problem number 111, minimum depth of binary tree. Okay, so you are given a binary tree and you have to find out its minimum depth. So what is the minimum depth? The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Okay, let me clarify what it is. We can do it on the tree visualizer option in leetcode. So as you can see in this tree, we have to find out every path from the root node to a leaf node, and you have to find out the minimum of it. So as you can see, this is a path from the root node to a leaf node whose depth is 2, and but for this is also a depth 127, but this is the longest depth, the maximum depth, and this is the smallest depth. Okay, let me clarify this example with one more example. So let's see, uh, if there is this tree and then I add like another node. So now as you can see there are 4 leaves to different heights. As you can see, this is at a height of 1 2 3 4, this is at a height of 3, this is at a height of 3, this is at a height of 3. So the minimum height is 3. So you have to find out the height from the root node to every like root leaf, and then you have to find out which is the minimum of that depth. I hope you understand the logic. So let's code it. Okay. So if on the base case, if root is equal to null, it means there are no nodes. No no nodes. Then you have to just return 0 because this is the minimum. Okay. Then what we can do is we can make a DFF function and we can insert root in it, and this is the first. Uh, this is the height of that root node 1. I can initialize a function in which we pass on the root node and the height initialized as 1 because it is at height 1, and we can return maxi. Okay, now what is maxi? We can make a global variable maxi which is at a very large value because we have to find out the minimum depth. So what we can do is we can make a variable maxi and make it very large. Then we make a function dfs, and we like give it uh, two values, uh, h and root. Okay, then if we encountered a root node, if we find out a node which is null, we have to just return because this is a void function. Else if we find out a if we find a leaf, how we can check it's a leaf? If the root dot left is equal to null and root right is equal to null, it means we are at a leaf now. And if the height of this leaf is less than maxi, so we store maxi equal to h, and then we have to run a dfs again on the root left, the left subtree, and we increase the height by 1. Why we are doing it? Because see, if we are at a first node, we have checked this node, then we have to go to the subtrees. But as you go to a subtree, we increment the height, we increment the depth, sorry, because now we are moving down the tree, and as we move down the tree, the depth increases. Okay, so yeah, and then we have to do the same for the right subtree. And then also, yeah, that's the code. Let's see, it's working. It's working. Let's submit it. It's giving the correct answer. I hope you understand the logic why I'm using it. If you have any doubts, please mention down in the comment box. Thank you for watching this video. Please hit the like button if you like this video, and I'll see you in the next one.